take a minute. Set an error going live on LinkedIn. And let me try that again. Hello, everyone. If we're live, we should be live. If anyone's watching yet, let me know in the chat and say hello.
Hi, guys.
Yeah, feel free to introduce yourselves. I'm just going to make sure that we're live in all the places that we should be. So, and again, it's always cool hearing from people watching, you know, where you're watching from, what you're working on, why you're interested in these topics. Feel free to share in the chat. So I saw it said there's 5 people already. And looks like we're live. How are you all doing this morning? Or whatever time it is where you're watching from. All right, so we should be live. We'll wait just a minute or two before we really get started. And we'll do intros in a second. But while we're waiting, if anyone wants to follow along, so this is kind of a workshop style event. We'll be running code from this Google Colab. If anyone wants to follow along, you can sign up for the requirements here. All you need is a Google account to run this Google Colab. So here's the link. The link should be in the YouTube description as well as the LinkedIn Live description, but I'll also share it in the chat. And then the only other things you want to do is sign up for a free Toloka account, and you can use this promo code drift_2022, and then sign up for a free WhyLabs account. And we're going to be using both those products today to monitor for data drift, and then we'll talk about how we can fix it with crowdsourced labeling. And I'll just share these links in the chat real quick. Oh, and I realized this might not go to the LinkedIn chat, so hang on one second. Magda, Dania, how are you all doing today?
I'm good. Thank you, Sage. Thanks for asking. And I'm really curious to hear where the people are connected from.
Yeah, I know chat can be a little quiet sometimes, but it's always way more fun if people talk in the chat or, you know, say where they're watching from, at least at the bare minimum, so we know someone's watching.
And we are really interested some unusual places you are now, because like most of the COVID restrictions are off and you are able to travel all around the world. Probably some of you vacationing in Maldives, for instance.
I'd like to be on vacation.
Yeah, but we have to, Sage, we have to work. We have to work for our audience.
Well, yeah, maybe vacation after we do this workshop.
That's a good idea.
Maybe I can come visit some of you all. All right, so I think we can go ahead and get started with the introductions. I've shared the links for anyone who just joined. You can sign up for the stuff you want if you want to follow along. You just want to create a copy of this Google Colab notebook. So once you get the Colab link, you'll go to File, you'll get Save a Copy in Drive, and then this will open up in a new tab, and you'll have your very own copy to follow along. So I'm going to follow along in my copy. And you can see that we were all kind of doing some work on this Colab notebook, and we didn't rename it. So we have a copy of a copy. We'll probably rename this later.
There are 3 of us working on this Colab.
So then
you may create your own copy of a copy of a copy. We need to I'm really curious what would be the length, the most lengthened name of this notebook.
Right, and once you create your copy, you're able to edit the text, edit the code in here, and then you could share your copy with a colleague if you want, or someone you might find it valuable, and they can make their own copy, and you'd have a copy of a copy of a copy, which would be pretty fun. All right, so once you do that, I think we'll be ready to go. sign up for those accounts that I shared, and then just hit save a copy and drive. And if you're not familiar with Google Colab, it's Google Colab's way of hosting essentially a Jupyter notebook, which is a popular tool where you can have text and code kind of all in one place. And it's really popular in data science and machine learning, and it's really fun for these types of live streams and workshops because you can take this copy and then run all this pre-written code that we have and just make some minor adjustments for yourself. All right. Do you want to talk? So we'll talk more about this in a second, but do you want to talk real quick about signing up for the Toloka account, Magna?
Yeah, I'll do it really quickly. So guys, you should have done it before, but I know probably many of you did not. So you can click on this account as a requester link that is added here. That should lead you to this page that Sage is showing you. You log in as a requester, you click on it, you have to fill in some information about yourself, your email, I think a phone number. So do it right now if you want to. And once you actually log in, you need to apply a promo code. The promo code, Sage, if you go to the notebook again, is drift_2022, all capital. The best thing, obviously, is to copy it from here and apply it in your profile page. Enter promo code. There is a screenshot here in the Colab. So I hope you can find it. If you have trouble doing this, send us a comment in the chat and we will try to help.
Cool. And real quick, so we'll go much deeper in this a little bit later, but what is Toloka for those who don't know in just like a few seconds?
So Toloka is a tool we're gonna use today to label data. This is just in one sentence what we're gonna do today with Toloka.
Yeah, awesome. And then real quick, again, you want to sign up for WhyLabs, you can just go to the whylabs.ai/free. And we're going to be using this tool to monitor data. So we'll upload input data. Today, we're going to be using images. So we have a computer vision project that we're going to monitor for data drift. And then if we and then talk about how to label or those images with Toloka once we're monitoring for data drift. So WhyLabs is a tool where you can upload profiles created with an open source library called WhyLogs, where you can measure things like data drift, data quality, model performance. And we'll talk more about this in a little bit, but just mentioning what those tools are, what you're signing up for, and then we're going to be using these together to detect data drift, and then kind of how we can fix it using crowdsource labeling for a computer vision problem, which will be really fun. And again, so we'll get started. We're actually going to be getting into I guess we have a couple intros first, but you're at the workshop, Detect and Fix Data Drift for Computer Vision with Toloka and WhyLabs. We just kind of talked about what those tools are already. Real quick, let's do some introductions for us, the speakers. Magna, would you like to go first?
Yeah, let me go. So my name is Magda and I work at Toloka. So I work as a data evangelist. So it means I create a lot of code examples and I share it with you guys. And previously, I have worked as a data scientist, programmer, and an NLP engineer across different companies in London, also remotely from US. My background is in AI. So this is what I studied in Edinburgh University many years ago now. And I'm also involved in teaching and writing about data science. So you can find me on Medium as well. And yeah, I think that's a short introduction about Riga.
I enjoy all of your Medium posts.
Oh, thank you.
And Dan or Daniel, would you like to introduce yourself?
Sure. My name is Daniel, or Dan, if you prefer. I'm a data scientist in Toloka. I'm working on our open source libraries, such as the ones we're going to present in this workshop. I'm working in Toloka for quite a while. Before working there, I was a machine learning engineer in different and even a CTO in different startups connected with computer vision for solutions for enterprise and healthcare. Now I'm pursuing my PhD, and I hope I'll get it.
I hope you'll get it too.
Thank you,
What
Sage.
is the title of your PhD then? Do you
Oh,
have?
it's so complicated, but it's in a somewhere in between of differential equations and computer science.
Okay.
Nice. And then I'm Sage Elliott. I'm a technical evangelist at WhyLabs. And I mentioned before, but people just tuning in, we create really cool stuff around ML and data monitoring and explainability. And we're going to be using some of those tools today to figure out how we can look at data drift. And we also have an open source library, so you can go to GitHub and look up WhyLogs. There's also links, I think, in the description. And I always appreciate, and I assume same with the Toloka open source library. It's always nice if anyone watching or appreciates this workshop wants to give us a star. It's always great for open source projects, getting a star on GitHub. We always really like that. So we have our open source data logging tool called WhyLogs, where you can create cool profiles of data to do powerful things like measure for data quality and data drift. And then we have WhyLabs, which is our kind of observatory store where you can send those profiles very easily just in a few lines of code, and then actually set up monitoring for anomalies there, and then get alerts or triggers that you can do various things with. And we'll look more at this in a little bit. So then it was our introductions, and then just real quick, so people who've been here at the beginning, they might know what we're going to be doing. But we're going to be talking about monitoring for data drift. So data drift means usually that the distribution of your new data kind of coming in that you're running predictions in on your model has changed maybe quite a bit from your original training data set, is kind of how I like to think of it. So for example, well, here's one example. This could maybe be a data quality problem. But if we trained our images and it was all kind of this light level, and then our input data now becomes kind of dark, that's quite a bit of variation between what we trained on and what our model is now seeing. And one example I also like to use for computer vision, which is what we're going to be using today, but data drift happens in tabular data as well. It's just really when the distribution changes a lot. One example is like if you had a object detection model and you're detecting some sort of animal outside, and you trained it all in the summer. So maybe you're detecting ducks and they're all on green grass, and now it's winter and the ducks are now in the snow. There's been quite a bit of drift in terms of like pixel values. Like it used to be maybe a green background, and now they're all on a white background. So your model, if it hadn't been trained on that data, potentially could be less confident or confused about detecting those objects.
Great, Sage. Thank you for this introduction. I hope everybody knows what drift is right now. And when we created this workshop, we wanted to work on a real case study. And we want it to be like complex enough so we can run this example, but simple enough so everybody can understand. So we decided to go with cats and dogs. So we're going to monitor a model today that distinguishes between pictures of cats and dogs. Simple enough. And just to make a statement here, I think Sage made it clear, but what we do here can be applied to any kind of image classification problem with more classes or more complex example, etc. So feel free to make a copy and adjust it to your own case.
Yeah, and all the ideas here can also extend to other problems that aren't just computer vision classification. So for any other NLP or tabular data, or even potentially other types of computer vision tasks like object detection, right? Like you can detect when something changes, if there's data drift or performance degradation, and then you can have someone label new data and retrain a model.
Yeah, exactly. And just to add here, probably every model will drift. Sooner or later, it will happen. So it's going to be useful for anybody like creating models. So let's get started. And first of all, we have to do some imports. So Sage, if you can run this one, or you guys, if you're following along, please run this one. What we are doing right now, we are importing Toloka kit, CrowdKit, it's another library from Toloka, and WhyLogs, and some additional libraries such as Asynco that we will be using during this workshop. This should not take too long.
Just do a quick note. If you haven't used Colab before, the first time you'll run a code cell, you'll see this kind of initialize. Once we're running, it should run code cells pretty fast. And then you can click this play button here, or if you're highlighted on the code cell itself, you can hit Shift Enter. So I often use Shift Enter, so you might not see me clicking the play button. But if you're more comfortable with visually seeing something and clicking on it, click that play button, and you can follow along with all the code here.
Yeah, cool. Yep, so if you scroll down,
First,
this might happen to you.
Yeah, because I know I've done this and I missed it. So because we installed a new version of Pillow, the library for reading in images, we want to restart our runtime. If we don't restart a runtime here, we might get an error when we're trying to read in our images. So we want this version of Pillow. You saw that window pop up. It said, do you want to restart it? We restarted it, and it should be restarted now. And hopefully we won't have any errors going forward. But if you do get an error later, like if you're watching this and you just ran it and you did not restart your runtime here, you may get that error. So just want to definitely point that out, that you should hit this button in this case.
Yeah, I totally agree. It happened to me before. So when I was running, and okay, next step is the next cell that we need to run, and this is just downloading all the data that we are gonna use today. It's just images of cats and dogs, structured in a daily manner. So you don't have to worry about it too much. We hosted it on the cloud before, so we're just downloading it right now. If you scroll down, the next cell will also download a model itself. So you can see Sage is running it right now. It's a H5 file that will be saved in your TMP file. And the next cell is downloading some project configuration that will be needed for Toloka later on. So Sage is running this one. This is just to check, okay, we have some data. You can see that in temp file, Toloka WhyLabs directory, day one, we have, 6, 7 images. That's all fine. It seems like all our downloads worked.
Yeah,
so
just to
Sage, what do we do now?
Just to reiterate, so we downloaded these images, and they're kind of in this by day format. So there's several images per day. So we're kind of, in this case, going to be simulating as if a model was running for multiple days. So we have these folders of 7 or 8 days, and we're going to backlog those into WhyLabs to kind of simulate like we were monitoring this model for 7 or 8 days, so we can see like how it's changed over time. So that's why we have it broken up into days. So we have our images, we have a model, because we won't be training a model in this workshop. We just already have one ready to go. I believe it's a TensorFlow model that we're working with too, right?
No, it's a Keras model, but I'll tell you guys a bit more later.
We'll get into that. All right, so first thing we're going to do is send this data up to WhyLabs. So when you're monitoring machine learning models or data pipelines, or you can use this method to monitor data pipelines as well. But when you're monitoring machine learning models, there's often several things you want to monitor. One is the input data. So in this case, we're going to create profiles, like I talked about at the beginning, of these image data sets, and then send those up to kind of look at some image statistics over time and see if they change. And that's where we'll start with here. And then you can also monitor model performance. So that could be things like, model performance can be with ground truth, which we'll get to later, where you're monitoring like the F1 score, the accuracy, but you can also monitor model outputs. So, the model's probability or confidence score and the classes over time. And basically you can look at all these things and see, do they change? Are they drifting? Is something going on with my data? And then kind of either visually inspect them or get kind of triggers for potential anomalies where something might have changed in your input data, something might have drastically changed in your output. So like if your model dropped in confidence a lot, you might want to go look at, did something happen with my data? Did something happen with my model? Did something happen with pre-processing somewhere? So there's a lot of stuff to monitor, and we'll take a look at, in this case, how to monitor that input data of images and then see if there's any big changes over time. So what we're going to do first is we're going to create profiles with WhyLogs. And like I mentioned, this is an open source library. So I'm going to share the link in the chat. If you want to go check that out, again, give us a star if you can. Always appreciated. Hold I'll share it here as well. So WhyLogs is an open source library for logging data pretty much any kind. With WhyLogs, you're able to generate summaries of their data. We call those WhyLogs profiles. And then you can use those profiles to do things like track changes in your data set, create data constraints, so you can actually look and do things like data validation to, does this data look like the way it should before I do something? And then you can quickly visualize key summary statistics. And you can do all kind of that in your Python or Java environment. And we have a lot of integrations that we work with. And these profiles that we generate, they're super efficient. So they don't contain a lot of raw data or any raw data. They're just kind of, sometimes I use the word like a fancy aggregate or summary of your data. There's actually a lot that goes into creating these summaries, but they're super efficient. They're lightweight, they're customizable, and then they're mergeable. So if you're streaming data as well, you can actually create these profiles and then kind of merge them over time to create different windows. And then creating a log, which you can learn a lot more in the GitHub. We won't go super deep into like creating a log and then looking at all the profiles locally on our environment here, but we can create a log and then send those summaries, those profiles up to WhyLabs, really in just a few lines of code. So it looks like this. We import WhyLogs as Y. We import the WhyLabs writer. You want to import your data set, and then you initialize the writer, create your profile, and then we're going to just send that data up to WhyLabs. And then there's just a couple keys you have to put in for your API key. So let's go ahead and actually run this with a little bit more, because we're going to backfill those 7 or 8 days, and we're going to read in images. So we're importing a few dependency libraries here, and pill, image from pill, which is the image reading library. And then before we can write to WhyLabs, there's just these 3 kind of tokens we want to set up. We want to get our API token, we want to get our org, and then our model ID. So at this point, you should already hopefully have a WhyLabs account if you're following along. If not, go to the whylabs.ai/free and then log in. You'll see a dashboard kind of like this. Mine has some projects in it because I've done some stuff in here before, but yours should be blank. What we want to do is create a project. We're going to set up a model because we're going to be using our own model and data set here. If you didn't want to follow along right now, you could also hit add a demo model, add some data. You can kind of poke around what it might look like in there. Let's go ahead and hit setup model. I'm going to give this a project name. You could say cats and dogs. I'll say workshop demo for now. And then we want to go ahead and select our model type. It's going to be classification, because we are going to be uploading some metrics like our ground truth before, and so we can read in our or create performance metrics. I'll hit create project, and then you'll see it has an ID. Mine is model-43. Yours might be a little bit different. It'll probably be like 1 if you've never created something in WhyLabs before. So I'm going to go back and I'll paste my model ID into here. Make sure you don't have any extra spaces happening. I know I've done that before as well. And then we want to just get our access token and our org ID. So you can go into access token in this little tab here, or if you're back on the dashboard already, you could go to settings and then go to access token here. Give this a name. Again, I'll just say workshop demo. You could give this a better name if you want. You can set an expiration date. I'll just hit create access token, and I'm going to hit copy here, which is our token. Paste it in, and then I'm going to get my org ID, which is also on the same page. You can see it here. So I'll hit copy. You can also see it right here. So I'm going to paste this into my org. It added a new line. Again, make sure you don't have any new lines or spaces in any of these. Hit Shift Enter or hit Run, and now we should have everything set up. So I'm going to go ahead and run this next code cell, and I'll walk through it real quick. Like I said, we kind of are backfilling for several days. So here we're saying, for in this range 1 through 8, 7 days, go ahead and add a timestamp. So by default, if you send a profile to WhyLabs without adding a timestamp, it'll be the time that it was sent up, but we're backlogging these for 7 days. So essentially we're just subtracting days as we go through and adding that to our timestamp as we're uploading them. And then we're looping through the folders for each day. And then we're making sure the file starts with JPEG, and then we're just getting that image path, and then we're opening that image with pill. And then here's where we create a profile. So we'll look at what actually is in this profile in a second when they get uploaded to WhyLabs. As I mentioned, like this, we have a specific image function, which actually I'll link to in a second. And then we're adding the timestamp, and then we're writing the profile up to WhyLabs. If you want to explore more of the image logging, we have an example as well in GitHub. I'll paste the link over there, but you can also just go to our GitHub and find these examples. So now it looks like we're done uploading these. Let's go back to our WhyLabs project. Let's go back to the dashboard. We can see I had this workshop demo one. That's the one that we just uploaded. Currently, there's no anomalies in range. It hasn't run any monitor yet. So we can go ahead and click in here. One thing I like to often do when I click into my projects is go to the exact profile lineage. So here we can see that profiles were uploaded for these 7 days, the 20th through 26th. I'm going to click on that. It'll automatically adjust the date here to that. And then I can click into one of these real quick. So we can see here are some of the or the statistics that we're collecting from image data, such as like brightness mean, standard deviation for brightness, color space, hue, pixel height and width. So these are all kind of things that we could track over time, and if something drastically changes, potentially get an alert triggered for them. So let's go look at image brightness mean, and let's actually click on this quantiles here. Now you can actually see visually that there's been some changes over time. So I can also drag over this, and you'll see some little stats pop up in that box, such as like the medium, the max for that day, and min. And so you can hover over and kind of see, okay, what changed a lot of these days. So you can actually see there's quite a few changes, and maybe that's something we might want to look at. Potentially there could be some sort of data quality issue or data drift happening because the pixels, the brightness mean actually has changed so much. So this is cool. We have a little dashboard. We can see when things might have changed. But what's even better is setting up some sort of automatic trigger. So when something changes a certain amount, which we can adjust, like how sensitive we want our monitor to be, then it can send us an email or a Slack message or trigger something with PagerDuty or some sort of integration where you can automatically do something like actually run your Toloka task and automatically label your data, which we'll get to in a little bit. So first, I'm just going to set up a monitor, though. You can hit this button here or go to Monitor Manager. And in this case, we'd want to set up our non-discrete input. So I'm going to enable with one click. And then I'm going to, I'm going to hit Configure. This might have added 2 if we do it this way. I'm going to hit Configure. You have some options. So you can enable with one click very easily, get this running. But you have some options if you want to tune it. Since we enable it this way, this is just showing that you can measure things like data quality, throughput, and model performance as well. But we have to set that up on the previous page. And then here we can say, what kind of distance do we want to measure, to trigger our drift. So in this case, we're using something called Hellinger distance, and essentially this is a good way of looking at, how much our data has drifted from those statistics that we saw. I'm actually going to make this more sensitive just for this demo, saying, if it's drifted above 3 or 0.3, then we actually want to have some sort of anomaly trigger. And I'll hit edit just so you can see here. By default, it does a trailing window of the last 7 days. So it's going to be looking back at your profiles every day and see was there a big change or not. But you can also do things like use a reference profile. So if you're just getting started putting your model in production, you actually might want to upload your training data set as a reference profile and then see how much data has changed against your training data set. You can also reference a specific range. So if you were like, I know that this is our summer data and now we're getting into winter data or something, maybe you want to actually compare against that as well. And you can change it from a longer trailing window. And then you can also say, how do I want to get notifications? I'm just going to do email right now, but you can set up Slack and PagerDuty. You can go to the notification settings page, also from the hamburger menu here. And I'll just hit save. And like I said, I accidentally set up 2 because I hit enable with one click. Let's go back to our inputs. And now by default, if we go back in here, look at this. The monitor is going to run. By default, it runs every 24 hours. And you'll get something like this. So this is one I've previously run before. So you can actually see these anomalies are caught here saying, well, the deviation changed enough from the way I tuned it to trigger some sort of anomaly. And so now we can do something like have it email us, do the Slack integration or some other code integration with something like a PagerDuty to do some other event. And with that, so we're monitoring now the input data. Like I mentioned, there's other tabs here. You can monitor the output data too. We don't have that yet in our Colab notebook, or like we haven't gotten to that yet. But you could see how you can monitor the input data over time for anomalies, but also the output. So again, you'd get something like this, and you could see what's the confidence of my model or probability that it's predicting between these several classes. And then if it drastically drops, have a trigger go. And then maybe that's where we say, hey, our model doesn't seem to be performing as well. Like it used to be getting 90%, now it's like only 30% confident. Now we might want to go look at that data and potentially have someone label it and give it ground truth, so when we can really get the performance, but also so we can retrain our model with it. And that's where we're going to go back to our notebook now and talk a little bit more about Toloka.
Yeah, actually, first of all, we're gonna do some predictions. So as I said, we have our inputs, but we don't really have the model outputs yet. So let's just have a look at the model that we have preloaded before. If you run the next cell, it should show us a short description. It is, as I said before, Keras model. It has some convolutional layers, some pooling layers, and in the end, it has just one decision if it's a cat or a dog. So we're not doing anything to the model here. We're just loading it. So the model is ready. If you scroll down, I just wanted to show you also how we're gonna collect those predictions. So as Sage told you before, we had our data divided into days, and each day had several images. So we want to have this information in a data frame. So this is actually what Sage is running now, creating data frames with all the information about each image. And right now, the one he's running is doing model predictions. So for each day, for each image, we predict it's a cat or a dog. And let's scroll down to this one to see what we get at the end. If you yep. So this is a final data frame that we have. So we have a URL. This is where our image is hosted on the cloud. We have a model score. So we actually know kind of confidence about how confident the model is about a cat or a dog. And then model predictions. So everything below 0.5, we treat it as a cat, and everything more than 0.5, we treat it as a dog. And let's actually have a look at few pictures and let's try to remember if our model is correct. So the first one is a cat, the second one is a dog, and then it's a cat. Let's see if the first image is a cat. Yes.
I'm sorry.
The second one should be a dog. So let's have a look.
Also, I'll just note real quick. So like the model score here, like that's something we didn't have before. We didn't log it to the input, but that's something that we can log in the WhyLabs output tab by adding the output to the column here. And then that's something you can monitor on. So like we could use that as a trigger to be like, our model doesn't seem, look at those scores and see what's going on.
Yeah, so exactly. And in this case, the model was super confident it's a cat, and it's clearly a cat. The second one should be a dog, and it's a dog. And I think I have only a third image. So, and that one should be a cat, if I remember. In this case, our model actually on these three images has 100% accuracy. This is actually an accident. I ran this model, it's not such a good model. Maybe it has a 70% accuracy if you take a representative data set. But I just wanted to show you how it works. So this is what the model does. But now we actually want to know what's the reality. So in order to get the reality, we're going to use crowdsourcing and Toloka. And this is actually, I would like to tell you a bit more about what Toloka is and what you will be doing. So if you scroll down a bit to see the first slide I added here. So a Toloka is the data labeling platform. So if you created an account at the beginning as a requester, you are actually people who are here on the right-hand side of this image, ML teams, data scientists, etc. And we are people who post labeling tasks to the platform. So this is what we're going to do today. We're going to create a labeling task that people on the left-hand side of this image, the lockers, will be performing for us. So actually, in this workshop, there will be people working for you. And scroll down a bit for the next cloud. And this is just to show you what kind of access to what kind of workforce we have. And you can see that people that take part, solve the tasks, are distributed all over the world. This is actually a map. You can see that they speak different languages. In our case, maybe it's not so relevant. It's an image. Maybe if you work with NLP, that could be a very important information. But the idea is that those people are available all the time. And probably many of you will run this workshop with us right now. And all this data will be labeled live by the people that you can see here in this crowd. So if you scroll down, and how this is going to happen, we're going to use Python SDK, and my colleague Dan will tell you a bit more about it.
So, Toloka Python SDK consists of two major libraries. First one is Toloka Kit, which is a Python API for programmatic access to Toloka. It consists of several submodules. We have synchronous API client, asynchronous API client. We have streaming submodule, which can be useful in the case you want to pass some data from one project to another. For instance, if you need to set up a project, whether there is an object you need it, whether there is a cat or a dog on a picture, and then you want to get a bounding box of this cat or dog, or even if this dog is cute. Also, we have metrics, which allows you to monitor what's going on with your pools and projects, and auto quality needed to you to fine-tune your settings, which I'm gonna tell you a little bit later. Me and Magda will tell you a little bit later. Also, we have CrowdKit. It's a library that have implementations of commonly used aggregation methods for crowdsource annotation. We also will dive deep into CrowdKit and aggregation a little bit later in this workshop. Stay tuned.
I feel like having someone judge if a dog is cute or not would be really hard to label.
Actually, it's funny. We did a similar project. We actually labeled if food was appetizing or not, and we got really interesting, subjective opinions on this. So it can be done as well.
Incredible.
So you probably question now how we're gonna connect to Toloka. So you should have created an account right now by this time, and if you need to get an API key, so the same as with WhyLabs. And how do you get it? You can see it here on the picture. You can also click on this profile integration link, the blue one, that should lead you actually to this page that you see here. If somehow it doesn't open, you just go to profile, then integrations, and you get the authentication token. I highlighted it with the red box. So I hope everybody have found it, because in the next one,
I'm gonna go get my integration token for the next code cell.
Okay, so this is
well, I guess I can run this code cell first. So I'll run this. It's gonna ask us for that authentication token. There it is. And then so you want to go into your account and where it was in profile, right?
Integrations.
And then you'll hit this button and it'll show it. I'm going to hide this tab real quick and I'm going to grab my token. But just click that and then it'll take a second. It reloads the page.
Yeah, Sage doesn't want to give us free data labeling for
I don't want you to take my promo code. I want to use it on a project. So I'm going to paste in that authentication code. And then I'll hit enter here. And then
so then right now you created the Toloka client object that is connected to your own profile. the money from your account that you have got, $30, should be connected to it. So you will be able to do data labeling. But actually, the first step is to create a project. And sometimes it can be a bit of a lengthy process. And usually this step is done by logging to our Toloka website and doing it via interface. And we're not going to do it during this workshop. As I said, it's too long. So I'm just going to explain you the steps that are needed to be done here. And the first one is creating a project, give it a name and a description. So in our case, the name is cat or dog. And the description, this is what people, when they see your task, just like a preview, they will see. So it specifies the type of animal depicted in the photo. That's all we need here. And this is when we proceed to the second step. So somehow we need to provide these pictures to people. And obviously it's done via Toloka, but we need to create an interface. So if you scroll just a bit down so we can see the button search. Yes, that's great. So how it's done is, again, in the interface, we have this template builder notebook that you can see on the on the left, like so-called in the config box. And you fill in this part in order to create what you see on the right-hand side. So in our case, the input is a photo, and people can choose cat or dog, only two buttons in our case. So this is something, obviously, if you want to do a different project, you would need to edit. And again, this is a very simple interface, but imagine you could have a video embedded there, you could have some text, etc. You could have much more buttons. All of this would be created here.
And just to be clear,
step,
just want to mention, like Toloka, you can label more than just images.
Yes, you can label a lot of different type of data, videos, images, text, or combinations of anything, to be honest.
For instance, one of our customers, they did an interface for 3D annotation, which is used in autonomous vehicles problems.
Yeah, so it actually, because you actually able exactly to use this kind of template builder, it's very flexible to how you can create this interface. And template builder is actually a tool we have created, so it's giving you like components, ready components, so it should be easy to pick up. But you can actually use also JavaScript. So, well, then the word is wide. You can do anything you want.
That's awesome.
And the third step, so if you scroll down, this is the last step in this setting up process, is creating instructions. So in our case, it's again very simple. Look at the picture, determine what is on it, a cat or a dog, choose the correct option. And because our problem is so simple, but imagine that you're working on something harder. This is where you can add some edge cases, examples, etc. You can use HTML here, so you can create tables, you can make something bold, whatever you need to kind of catch attention of a user, you can actually do here. So this is the last steps. Those are the instructions. And done.
I like that you pointed out you can add examples of like good and bad. So I know if you're making data annotation instructions, right, it could be hard, especially if you're doing a little bit more of a complex task like drawing bounding boxes or segmentation around things. And so like you mentioned, you can embed HTML or images. So one thing that can be really helpful is, create several images of like a good annotation and a bad annotation and add those to the instructions.
Exactly. So I told you already, we were trying to annotate food in the past. So one of the objective questions that we tried to do was to ask if a food is solid or liquid. But then this is actually when I added examples like, is ice cream solid or liquid? Well, I don't know. So actually, this is the place where you can specify all those things.
For anyone watching, let us know, do you think ice cream is a solid or a liquid? I think that'll be a fun poll for people to talk about.
Yeah, and Dan created a script to actually automate it here in this notebook.
Yeah, as in Toloka kit, we store all the Toloka entities as classes. These classes are serializable and deserializable. We can use, as is shown in this small snippet of code, we've already created a project configuration for you, and you may just read this configuration file and pass it to Toloka to create it from these JSON strings. You may do the same with your projects, and you may pass your project configuration using this feature to your mates, to your colleagues, or to no, you won't do this with your enemies and competitors. So
you could.
the next essential part is creating a pool. Magda, what is a pool actually in Toloka?
Yes, so you already created a project, and now you need to start choosing people that will take part in your project. So not everybody will be able to take part, and also you have to control the process. So you need to do some quality control, and then when you gather your results, you need to somehow aggregate them together. So actually, those are four main steps that you can see here on this slide. So the first step is choosing the crowd, and just to tell you how you can, for example, choose people, you can specify what language do they speak. You can, your Talokers feel like what age they are. You might actually use this as well. If you run a specific study, for example, you require them to be on a specific device, you could actually choose this there. Then once you've chosen the crowd, it's a good idea to train them. I think in our example today, we don't do it, but this is when you actually can give some examples to them so they can try on the task and you can see how well they are doing. And this is also a place if you have provided some edge cases in instructions, you explain what they are. This is a time actually to reiterate and reteach people how to do that. And then throughout the project, you have to focus on quality controls. And we're going to talk a bit later about it. And the last step is actually aggregating the results. So in crowdsourcing, one task will be done by more than one person. Usually we send it to several people. So then we have to figure out what the final label is based on all their answers. We're gonna go into details a bit later on. And I think first of all, I wanted to tell you about some quality control rules that you could apply. So Sage, if you scroll down, yeah, the simplest way quality control rule that you could use in crowdsourcing is using those catches. And this is actually very basic. So it's just usually to avoid kind of automated traffic. We put catches every few tasks. So if you are a human, you will solve it and proceed, etc. And they are really a lot of different type of quality control rules. And we're going to actually talk about two more. One of them is fast responses. So if you just scroll down a bit so we can see the full second slide. Okay, this is another simple rule where you check how long someone is taking to complete your task. If you know that looking at the picture of a cat and dog should take 5 seconds and decide on what kind of animal they are, you actually can set up that all the answers that require less than time will not be accepted on your project. And in our case, probably this is a very Not a very good rule. Our task is very simple, but imagine tasks that require someone to take 20 seconds and they're doing it in 5 seconds. They're basically not doing it. You don't want them to take part. And it's very important to use. And I think the most common control, the quality control rule are control tasks. And I recommend probably to use it for almost every project. And this is actually when you imagine you have 100 images of cats and dogs, but you actually label 10% of them yourself. And you know what are the exact labels. You basically put those tasks in between other tasks, and you will be able to measure how well people are performing on those. And you can decide what threshold you want to use. You might require them like 100 to be 100% accurate, like in the case that I in of this screenshot here. And this works probably for very simple tasks like our one, but you might put this threshold somewhere around 70, 80 if something is more complex and you don't want to lose workers who are doing well, but occasionally can do some mistakes as well. So actually, Dan is going to tell you what exactly quality control rules and how we choose them for our project here.
Yeah, we decided to create one pool per day and to set up all the pools in a good manner. As we are engineers, of course, we'll create a method which will do so. So let's go through this pool configuration. There are two essential things you should have in your pool configuration. Project ID, it's like which project does this pool belong actually. We highly recommend you to set up a private name. It will be visible only for you, but it will help you to distinguish between several pools. For instance, you may use with different control with different quality control rules or different languages, etc. Also, you should show a reward per assignment. It means that our performers, our Tolokers, will get this amount of money in United States dollars for each correctly performed. Sorry for this assignment. Also, it's highly advisable to give the amount of time which is needed for our laborers to do this task. In this case, it's assignment maximum duration per second. In seconds, we set it into 2 minutes, and expiration parameter for the pool. When the pool is expired, it goes to archive. So let's go also with defaults in our pool. We set it not to do so in tasks when create tasks. In this case, we create a default overlap for tasks to be 3. It means that each image will be labeled by 3 different Tolokers. Also, we'll set number of tasks per page to be 10. So our Tolokers won't be paid to do only one labeling, only one picture. They need to receive. They need to do so in 10 minutes. Oh, sorry. They need to do 10 images in 2 minutes and do it correctly, of course, to receive 1 United States cent. Also, we'll filter our Tolokers as we have instruction in English. It's like highly advisable to filter our Tolokers. We're not really sure whether they know this language, but you may filter them by language. Set capture frequency, as Magda said, we set it to medium, and we also create some quality control rules like history of captures, fail rate, and also restrictions. So if somebody will if somebody will be banned for 1 day in the whole project if they will not eligible for this quality control rule. For instance, if they did in this case, if they did capture more than 5 times incorrectly. Sage, could you please go next? So yeah, we've created our pool, we've set up everything. Let's do this.
Should I go ahead and run all these
Yeah.
code cells?
Could you please run it?
Yep.
And yeah, now we'll have our pools created, tasks are all being also created, and I would say a little about, as you know, we use synchronous API and asynchronous API. We upload data via synchronous API, which means that you cannot run this simultaneously. It goes step by step. It creates a pool for the first day and upload task for the first day, for the second day, and so on. But we really want to label these pools, to run these pools for labeling simultaneously. And we use this method, wait pool for close. We use a synchronous API to do so. And you'll see that we'll receive the data for the whole day, for the whole 7 days, much faster, like within 2 or 3 minutes, like we get this labeled. Okay, let's wait a little for the tasks. Yeah, tasks are created. So Sage, let's now wait for for our tasks to be labeled by Tolokas. And Magda, could you please tell us a little bit about aggregation? So we have this each image labeled by 3 different people. How we can combine these results into one?
Yeah, let's talk about it. But even before that, I just want our users to see what's happening right now in Toloka, just to give them a real life picture. If Sage, can you go to Toloka, tab, and you can click on the, I already knew what to do. On the top one, this is the one you created today. So this is our cat and dog project. And you can see all the pools are ready here. So we have day 1, day 2, day 3, all the way till day 7. And you can see that the status is labeling. So people are working on it right now. Right now, if you look at the progress, it's 0 in all of them. I believe, Sage, if you refresh it right now, please, the page, hopefully some of them already has been started. Great. Some has been started and some has been finished. So be aware if you guys running it with us right now, there might be a lot of labeling being done simultaneously on Toloka. So let's see how long we're gonna wait for it. I think Daniel, as Daniel said before, when we ran it on our own, it took maybe 2 or 3 minutes.
Yeah.
So once this is happening, let's go back to the notebook and I'll tell you a bit more about the aggregation. So this is a concept that we kind of introduced a bit before. So Dan, me, we already told you that one task is sent to multiple performers. So how can we then figure out what the final label is? And the simplest way of figuring it out is using majority vote aggregation rule. So if you scroll down, Sage, to see the full slide here, this is the most basic rule probably that you can think of. If we have 3 labelers, and here on this example, 2 say that a picture is a cat, 1 says it's a dog, well, we're pretty confident it's a cat. The majority wins. However, this might not be the best way of doing things. For example, imagine if if the guy who said that this picture is a dog, like, hey, how come if he is a better worker, like, should he be counted the same way as 2 other labelers? Well, so this is a very naive method that does not take into account how well each labeler is. And there are variety of aggregation you can perform, and a more complex one we can see on the second picture, second slide, if you scroll down Sage, and it's called David's Kane algorithm, and it is used a lot in classification, so it would fit our example well. And this is an expectation maximization algorithm. So it's an iterative algorithm that takes all the labels done by our labelers and try to match them. So as you can see here on the picture, the second and the third labeler, they labels match perfectly. And the first labeler, they do not match with any of other labelers. There is high probability that this first labeler is actually not doing something right. He might be clicking it randomly. He might not understand our task. Well, whatever happened here, he is not agreeing with others. So his quality of work is probably really well. And this is how this David Skin algorithm, by looking at how well the answers match, can figure it out. And that's why it's an iterative process. I'm not going to talk about the details, but the implementation of this is in CrowdKit. And I believe Daniel will tell you more about it, but I don't know if we should check first if the data has
Yeah,
been
let's check first that the data
labeled.
is labeled. Sage, could you please go back? Yeah, we have some pools. They're already closed. Some of them, they need some labelers to label them. If we proceed to our profile, to our project page and update it, yeah, now we may see that we have two pools already labeled and already closed for labeling, and the others, they're just waiting for some while for the labeling to be finished. And after that, we'll be able to run aggregation. While we are waiting for this pools to be completed, let's go and take a look into CrowdKit, our second library. So CrowdKit is a library which is used to aggregate the data using really interesting mathematical and computer science algorithms. You may use CrowdKit to combine the data, to aggregate the data of any kind. It may be categorical data, even multi-label data, texts, image segmentations, and pairwise comparisons. When you have two items to be shown by two Tolokas, and then using CrowdKit, you may range them, which is more likely to like which item is the most applicable to your task. In this case, we have a categorical responses. We will use a simple majority vote algorithm. So Sage, let's try and run it.
I think we're still waiting for the labeling
Yeah.
to complete. By the way, if anyone watching, you can run the cell. Also, maybe your labeling's done if you're running this as well already. But you can go ahead and
some of our audience catches our Toloka's attention. That's why we are waiting for it to be finished.
Actually, let's explain why this labeling, sometimes the last example lasts so long. So from my experience, it always does it. So imagine, remember we set up something like run out time, and it was around 2 minutes. So if someone picks up a task and is doing this labeling, but actually, well, got bored and he decided to abandon it, we have to wait those 2 minutes till the new person can pick up this task. So usually this is what's blocking those.
Gotcha. And it does look like we're done now. So I saw that, I know that from the favicon changing from gray to orange. And if we went back to our project, I can refresh real quick and we'll see all these done over here.
But what Magda said, it doesn't mean that you should pass You should allow our Tolokers to label in the minimum amount of time. It should be like a reasonable amount of time, not 1 hour, but not 1 minute, probably.
Yeah, imagine if we set it up to 1 hour, now we would be waiting maybe 1 hour if someone would be blocking it. Yeah.
Yeah. So, Sage, let's run this code. We get our results of our labeling in Python in the pandas data frame, which is passed to majority vote using fit predict, and then we have our predicted answers. Let's run this for all the pools we have, for all the days we have, and yeah, and now let's take a look into some random kind of days. Here you can see that in some cases, our human annotators, they agreed with the model. It's a cat or a dog, but in some cases, they disagree with the model, while our model is, well, is quite sure that it's a cat. Our annotators suggest it's a dog. Let's have a look into the 6th day.
Interesting.
What's going to be in the 6th day? Oh, look, we have, I believe, 2 items where our human annotators, they disagree with the model. And the model is quite unsure. The model score of 0.5, 0.53, for instance, it's like, it's on the edge. It means like somewhere between. Probably that's, we need to, if we see this model scores, it means that probably we should fine tune our model. But, well, we need to be 100% sure what's going on. So let's analyze this metrics using WhyLogs and WhyLabs. Sage, the stage is yours.
Yeah, so we'll go back, and like I'd mentioned, you could be monitoring these output scores and classes for some sort of anomaly there. And then now that we have the ground truth with Toloka, or before we had the ground truth, you could have had a trigger being like, hey, when we think the model confidence has dropped or there's been data drift, do some sort of trigger to like, we had all the code there, which is awesome that we could just run those code cells, and we had labelers working for us getting ground truth data now. And you can use that ground truth data to analyze the metrics. So we're going to look real quick at the full performance of the model. But you can also use that, now that you have that ground truth data, you could use that same data from the data annotators to retrain your model, and then hopefully create a better model based on the current state of the data. So like, your data might drift, your model performance might drop, and then you want to, typically, how to fix data drift is to take those situations where your model wasn't performing as well, label them, and then train a new model or retrain a model with those new annotated, in this case, images. So it's really cool that you could see that you could really kind of automate all that process, and then you'd probably want to look in at it, make sure that it does look correct. But technically, we could automatically have a trigger when something drifts like that, do everything with Toloka like we just saw, get the ground truth, see how the performance did drop, and then retrain a model, which is really cool to see, like, everything in code. So we're going to do, this is kind of similar to what we did with the uploading the image profiles before, except for we're uploading a few specific items here from the data frame. We want to upload that ground truth, the model score, and the predicted class. So again, we're just kind of looping through all those data frames to backfill the days, adding a timestamp like we did before to backfill them into WhyLabs. And you can see we're passing this data frame, and then these are those specific columns. So the predictions, the model predictions, and then the model score. And this is the ground truth column there. And then this is the actual profiling, where we create a profile with WhyLogs, and then we're going to write those results to WhyLabs. So go ahead and run this. And then if we go back to our WhyLabs project, this is the one that we just created before. We'll see performance metrics in here. So these are your kind of classic classification performance metrics, as well as you'll see total input and output over time. You'll see accuracy, how that's changed over time, your precision recall, confusion matrix, etc. You can see recall down here. You can see these really changed a lot and dropped from our ground truth and model. So
We have a
precision
recall slippery slope, I believe.
Is that's the technical term for it, I think, right?
Yeah.
You can see
We've invented it, yeah.
you can see our precision F1 score drastically dropped. It was pretty high, and then all of a sudden it went to 0. So we obviously had a problem on one of those days with our model. What's cool in WhyLabs, just like we did for the inputs, is you can also set up monitors for this type of data. So if you go back to the monitor manager, you go to this presets is one of the easiest ways to set this up. Scroll down, we have our drift detection, we have our data quality, but we also have model performance. So I could actually enable this one for the F1 score, for example, or precision, or any of these other metrics. And then when the time passes and the trigger happens, we'll actually see, and I'll go back to our other model that I built yesterday. I scroll down, I enable that, and you can actually see that our F1 was looking pretty good, right? Like it's in the 90 and 80%, and then here it dropped to 60. So it's saying, whoa, there's a big drop there in performance. And so this is really cool.
Sage, is it the day where we've not the WhyLabs platform have noticed the data drift?
Oh, probably. So we can go back and look in our profiles, actually. And actually, if you do this in an output tab, I didn't have this in this workshop. We actually have a newer feature where you can look at these outputs and then more easily find the correlation between like inputs and performance drift. So we'll have some cool stuff coming soon that makes it even easier to see those correlations between these different log tabs, which is cool. But sorry, let's go to performance. We'll see that here it's 10/23 through 25th, I believe, right? And if we go back to our inputs, let's look at just this mean, for example, the quantiles, and it's the 23 through the 25th. So yeah, this is a great way of like seeing the correlation, right, between the data we predicted that it drifted here. We saw that, it met a certain threshold and it moved quite a bit, and then we saw that our performance did not do so well when we got the ground truth in, and we can correlate that definitely back to these the data that came in on these days, which is pretty neat.
And just to add here, and this is probably correct. So what I did to this data set, I blurred some pictures later on. So actually it was getting harder for the model.
And we like as we had a copy of copy, I've also made some things with the data set, so as it will be, if our camera was kind of not really good, it is blurred. Some parts of it, like we have broken pixels, so our data is really corrupt, and it is detected in this case. And I believe that this is cool because you may notice these things which are, well, you won't be able to look through all the photos or the whole day of the data being shot using, for instance, CCTV or something. But with if you set up this data drift monitoring, it will be easier for you to notice that something is going wrong.
Yeah, and then like we were saying, we even noticed something went wrong just on the input side, and it's really cool that you notice it just from the input before we even had the ground truth, and then you could do something like trigger these ground truth automations or ground truth labeling with Toloka just from that trigger happening there. And then we say, well, we could go manually look, but maybe there's a lot to look through. We're busy building other things, that you can have this automatically send a trigger to something like Toloka, have someone else put in that ground truth, and then get an alert here too that yes, something did drastically happen to your model performance on that day, which is really cool.
Exactly. And just to follow up on this one, so we had a lot of trouble. Well, not a lot of trouble, but it took us a lot of time to set up the project in Toloka. But if the project is already set up, well, you just create a new pool and you start the labeling. This is the only parts you need to do.
Right. So it's even like we did a whole bunch in this workshop, but a lot of it you only do once. And so it's actually way easier. Like you don't have to do all the code that we did today, like repeatedly over and
Exactly.
over, right? Like we already have a project set up now. You could just do the pool, have something trigger it, and then have people label the data.
So we've
Exactly.
shared this life hack with you, but don't share it with your boss.
Um, awesome. So that and that kind of went through like I think we've seen kind of all the various steps. I know a lot of it we went through pretty fast. So if you've never used something like WhyLogs or WhyLabs, you might have questions about it. Same with Toloka. Like there's so many cool things that these projects can do. And I definitely encourage everyone to go visit the GitHub and documentations or the websites for sure. I know we kind of did like a super quick crash course in like data drift detection and data annotation, and not everyone has used those before. So you hopefully get an idea of like what these things can do and how you could use them in your workflow if you're not already. But definitely check out the links at the bottom of the Colab. I think they link to everything that people might have questions about: the documentation, the websites, and the GitHubs for both Toloka and WhyLabs.
Yeah, exactly. And I just wanted to add, like, if you like this was as Sage said, very short introduction. And if you think like, oh my god, but like my problem is totally different, it's so much more complex, I'm not sure if this solution works, or well, if you're not sure, please contact us directly. I think Sage on WhyLab side, or me or Dan on Toloka side, we will be able to help you. Like, we will be able to guide you if this problem that you have can be done with Toloka, or maybe it can't, and we can try to figure out something. I think we added some links that goes directly to our LinkedIn profile, so you can reach us there.
Yeah, LinkedIn's usually good, and I think we both have links to our community Slack channels as well, which is also good to ask questions in. You might have even other people that have experienced the same problems or have had the same questions before, and then often, I assume yours is the same, where you have several people from Toloka probably in there that are able to answer those questions as well.
Exactly. Yes, we
Yeah.
added a Slack channel there as well. Sorry, Dan.
Yeah, sorry, but I just wanted to add, as Sage mentioned in the beginning, somebody is going on vacation. In this case, our Slack communities would be much preferable because you'll get the help from all of our colleagues.
Yeah, totally. So either directly or even better in the Slack. In well, I guess the advantage of the Slack is that it's a community. So even if I personally have not encountered a problem like you have, probably other people using Toloka, they did, and they already solved this problem. So you can find help there.
And I always like to mention, it's always fun to connect with people and see what other people are working on. So usually, there's like an intro channel or something like that, and it's always cool to introduce yourself and maybe put what you're working on, even if you don't have a specific question or problem that you're encountering right now. And then people will know that that's the stuff you're working on. They might have a question for you, and it's really cool to stay connected with other people working in similar fields. So I will
Yeah,
ask if
totally.
Oh, I'll just say
Sorry.
if anyone that's still watching right now has a question, you could put in the chat because I think we can go for a few minutes longer. But we'll end the stream soon, and then if you do have a question later, like Magna said, you can find us on LinkedIn or in the Slack channels, and feel free to ask questions in there as well. While we wait for potential questions to roll in, because I know there's often a little bit of a delay too from us talking to each other and the live stream. Is there anything else you want to add in about Toloka or anything else cool that you're working on?
Well, Dan added some links here. We actually have a lot of examples on, if you go to Toloka Kit.
Yeah,
If you go to this one,
there is a
we have
direct
a
link
lot
to
of.
Tolokit. Yeah.
Uh-huh. There will be a lot of use cases. I think this is probably what people find most useful in the examples folder. And they cover like a variety of projects, like some project basics, but NLP, video classification, image classification we just done, but like drawing bounding boxes around objects and working with audio files. They are really, well, I think there are 10 different examples there, so you can browse through them as well.
Very
And
cool.
also, you may create a new pull request and provide us with your own cool example if you have some.
That's a great idea. Any maybe last words on I'm blanking. Advice on writing good annotation prompts, like, you know, we mentioned, like, have I guess be very clear about like what you want done, and then if you can add image examples. I know that's really helped in the past with me.
Yeah, we actually can do the whole lecture on this.
We have like 4 or 5 hours tutorial on how to do this in a good way, in a like to not so as you get the best annotation ever. But well, we don't have so much time.
Yeah, that'll be
It's
that sounds like a cool workshop though. You should put on, if you haven't put on, like a how to do, or how to clearly write those prompts. I think that would be actually pretty valuable.
Yeah, we actually have done something like this. I would have to find the link. So we actually ran some lectures how to do it. We've done a course on this, etc. I don't know, guys, if it's something you would be interested, comment here, and maybe it's something we could do a follow-up in the future.
Yeah, that sounds great. And I'll just mention, comment if you're watching this as a recording later. Feel free to comment in the YouTube comments or LinkedIn Live comments if this isn't live anymore, and we'll see it.
And also, guys, I think we had so much fun preparing this workshop, like all three of us. I hope you can see it. But we would love, I think, to hear some feedback from you. Like, did you like it? What could we do better? Was it interesting to you? I think if you can leave some comments, that would be great.
Yeah, and
And
maybe
if you
people.
have some interesting, sorry, Sage.
Oh no, you go ahead.
Thank you. And if you have some interesting topic for us to talk, also please leave it in the comments. We'll come up with it.
I was gonna say, I think it'd be fun too. I don't know if people are interested, but doing a workshop where, and maybe it's longer or something, but we train a computer vision model, and so maybe we even do, or right, if you could do like Toloka doing the annotations on images with without any annotation so far, not just basically do annotations, train a model. I think that, and then monitor it. That would be a kind of a fun workshop too, a little bit more hands-on on the training side, maybe for people who haven't done computer vision before or use something like TensorFlow. I think that could be a fun one as well.
I agree.
I don't see any other new questions coming in. So I think we'll go ahead and end the stream, because I know we're already over 20 minutes over the initial time that we said. So, but I think you're right. Like, we had a pretty fun, or a lot of fun doing this workshop, and hopefully people found some value out of it. Maybe if you've never thought about data drift before, you'll look at using something like WhyLabs, or even if you have thought about it but you haven't implemented it, WhyLabs makes it really easy. And then, as we saw also, Toloka really makes like the data annotation part. It felt so easy going through our workshop and running everything. I know, like, creating the project could take a little bit of time, but it was so cool just to like run it and then have people in 5 minutes or whatever label all of our data. That was just so awesome. All right, so I think we're going to go ahead and end the stream now. Thank you, everyone, for watching, and yeah, stay connected with us in Slack or LinkedIn, and everyone have a great day.
Yeah, thank you, guys.
Thank you. Sage, Magda, it was a pleasure to give a talk with you.
Likewise.
Yeah, likewise.